let's begin with the label encoding or ordinal encoding. So label encoding or ordinal encoding. So we use this categorical data encoding technique when the categorical feature is ordinal. I'm repeating again. We use this label encoding or ordinal encoding when the categorical feature is ordinal. In this case, retaining the order is important. Hence, the encoding should reflect the sequence. So in label encoding, each label is converted into an integer value. So you will create a variable that contains categories representing the education qualification of a person or that sort. Let's take a small example on the screen. So this is your customer feedback. We call this as a 5-point Likert scale. So in this scale, the feedback is poor, fair, good, very good, excellent. So you might have received 1,000 data points or 1,000 feedback from 1,000 customers, and each has given either one of these ordinal category, either poor, fair, good, or very good or excellent. Now if I want to encode these categories which comes under the ordinal category, I need to assign a numerical code which has a specific order, because fundamentally this category is ordinal categorical variable. So that is the reason whenever I encode this, I need to keep the order in my mind. So that is the reason for poor I put 1, for fair I put 2, for good 3, very good 4, excellent 5. Okay, so that's what is the assignment. So now this is what is called label encoding or ordinal encoding. This is pretty straightforward. Now let's take one simple example to understand this pretty much better. So let me type as, so this one is label encoding or ordinal encoding. So label encoding is the process of converting categorical variables into numerical labels, where each category is assigned a unique integer value. So this can be useful when dealing with ordinal variables where the order of category matters. I'm writing it again, where the order of the categories matters. Okay, so now let's take one example. Let's import pandas as pd, then from sklearn. Obviously we need to go for the pre-processing module and import label encoder. I'm directly using a method, no, I'm directly using this label encoder method from pre-processing module from sklearn. Simple. Now let's create a sample data set. Let's create a sample data frame. So df is equal to pandas dot data frame, and inside that I'm gonna put a dictionary red. So here I do not have, I'll go for same poor, then let me look into this one more time. Poor, fair, good, very good, and excellent. fair, good, very good, and excellent. So this is my data set. This is my data frame. If you want to see, I'll just show it to you. Yep, this is what my data frame. I'll just copy paste. I'll repeat this. I'll repeat this here too. Yes. So this is what is our database, data frame, and you got fair, good, very good, excellent, and there are a lot of combinations. Okay, these are how many customers? This is total 20 customers feedback. Okay, 20 customers feedback. Let's do analysis now. Let's do the label encoding. So to perform label encoding on this column A or feedback column, let me put it as a feedback, or let me put the rating, yep, on column rating. So let me take the label encoder name, variable name, label encoder variable name, and then obviously I'll take up the method. And so when I call label encoder, so label encoder method comes in. So I will attach a new column to my data frame saying rating label encoded. This is what the new column I want to attach, and this is encoded rating column. So let me call the label encoder, and then as now I have to fit transform this one. I call the so now let me fit and transform this. Which column I want to transform? I see here what I'm doing. I have the label encoder method, and then I'm using the fit transform method, and inside that I'm gonna give a column. So what it will do is, let me add the column first. Rating. So what it will do is, whatever column, whatever data you have given, so that data will be transformed by this method using this. Okay, this column will be transformed into this label encoding. That's what the meaning of this statement. Now let me print it. That's it. df. And here is that. Fantastic. Now, so rating and then rating label encoder, and so the fare is 0, and then after that you have 1, 2, 3, 4. So the 4 got the highest one. Okay, now let's customize even label encoding also. So here we face some issues like now pour 3 it has taken randomly. So let me do that. Let me do it our way. So we have our data frame. So this is our data frame, correct? Now this was label encoded with the previous one. So I'm gonna take a new data frame now. So let me copy this and put it here. So let me say DFL and change everything F good. Let me bring this to here for F change this back, change this back. Yep, done. So let me check it. DFL. Yeah, fine. Yep, this is our data set is ready. Now let's define the custom mapping for label encoding. That's what I want. Let's define the custom mapping for label encoding. So mapping is equal to, so first one is poor, so I want to map it with 1. That's it. Sorry, 1. And then second one for us is fair. I'll put it as 2. Then we have good. I'll put it as 3. Then we have very good. It would be 4. Then finally excellent. So it will take up 5. So our mapping is ready. If you want to see here, it's a dictionary. Done. Now let's perform label encoding using a simple map function. Now simple map function, we call this as an iterator also. We call this map function as an iterator in Python. So let's perform label encoding using the map function. So DFL of rating label rating custom LE label encoding is equal to, very simple, and it's rating and apply map and mapping. That's it. And DFL, and here is your, okay, there is something else left. Let me cross check that. And here is your data set. Yep. So rating custom label encoding and fair. So one fair got left. Let me cross check. Let me change that where it is. Yeah, here. Yeah. So now every part, the rating has been encoded. The ordinal rating variable has been encoded with the numbers, numerics, which has a order. So obviously 1 2 3 4 5, they have a specific order. So now you can do respective statistics on this data, and this is called as label encoding or ordinal encoding. So I'm just repeating one more time. Label encoding or ordinal encoding is a technique used for transforming categorical variables into numerical variable numerical representations, where the categories that have an inherent order or rank, so, and the order of categories matters.